So section 5.1 and 5.2. 5.1 are identities, and 5.2 is the sum difference formulas. So I've combined them into one section because they overlap a lot. So sometimes to solve identities or to verify identities, we need the sum difference formula. So we have a lot of different identities, and unfortunately you have to memorize them. The Pythagorean identities are all derived from the Pythagorean theorem. So we actually derived this one already by using what we knew about the unit circle. We saw that x, right, represented cosine, y represented sine, and when we squared them we got 1. So we can also verify these identities by turning them back into sines and cosines, and so we can see that secant and tangent kind of belong together, and cotangent and cosecant belong together. Opposite angle identities, right? Cosine is an even function, so if you plug a negative value into it, it comes back as cosine. Sine is odd, so if you plug a negative angle into sine, it's the same thing as -1 times sine of the positive angle. Tangent is also an odd function, so it's symmetric about the y-axis, or symmetric about the origin. The reciprocal identities, we've been kind of using the whole review. Quotient identities are how we break tan and cotan up into their cosine and sine equivalents. And this should not say quotient. This should be the sum difference formulas. So technically these could be called identities, but you can't really verify them in the traditional way. But if we have sine of two different things being added together, we can separate the variables into individual trig functions by using these formulas, and then we can do that. We have one for cosine and we have one for tangent. Notice there are differences if you're adding or subtracting. So what we're going to be asked to do in this section is verifying that an expression is an identity. So a trig identity is any equation involving trig functions that it's got to have two sides where the left side is equivalent to the right side. So you can't memorize all the identities. You use this information to verify the identities. There are literally hundreds of these. So there is a method to verifying an identity. And the first thing is you pick one and only one side of the equation. You manipulate that side of the equation until you turn it into the other side of the equation. So the easiest kind of plan of attack on these problems is look at what the most complicated side is. It's much, much easier to combine and reduce things than it is to try to take something that's simplified and expand it out. So for this identity, this is obviously the more complicated looking side, right? It's going to be very difficult to turn this into this. So I would start with the left-hand side. So I'm only going to write that side down. Right? So I'm not even writing this yet, because what I have to do to verify is I have to just work with this and turn it into this. You are not allowed to work with both sides of the equations together, okay? So this is not an algebra problem where we're solving for x. We are verifying this identity. So I have two fractions. So the obvious first move to me is, well, let's combine them into one term, because I have to reduce them to a single term. So I got to get a common denominator. The common denominator is going to be 1 minus sine of x times 1 plus sine of x. So this first fraction is missing the 1 plus sine of x. So if I multiply the denominator by that, I have to also multiply the numerator by that. Over here, this guy needs 1 minus sine x. So now what I'm going to get is I get 1 plus sine of x plus 1 minus sine of x all over 1 plus sine of x times 1 minus sine of x. In the numerator, I have a positive sine x and a negative sine x, so they add to 0. Not canceling them, they just add to 0. The 1 plus 1 adds to 2. In the denominator, I have an a plus b times an a minus b. So if you actually FOIL this out, you get a squared minus b squared. So this is a difference of squares, and this is what that factors into. So I recognize that, and I was able to multiply it out quickly. If you did it by FOILing, you would get 1 times 1 is 1, positive sine x, negative sine x, which would cancel, and then negative sine squared. So I'm much closer to where I want to be, but not quite there yet. But the sine squared is really like standing out to me. So if I go back up and look at my identities, I actually have an identity involving sine squared. So if I take this guy and solve it for sine squared, I get 1 minus cosine squared, right? But if I solve it for cosine squared, I get 1 minus sine squared. So we actually used that way back in the very first section when we solved that problem 6, I think it was like 6 sine squared minus 7 cosine squared x. So I actually have a 1 minus sine squared in my denominator, so I can replace it with cosine squared. So now I can say that this is equal to 2 over cosine squared. And I know 1 over cosine squared is secant squared. Oh, I changed my variable accidentally. This should be an x. This should be an x. So the minute that I get this guy worked out to match this, I'm done. And that equals the right-hand side. So I know I've verified it right. Notice at no time did I copy down the 2 secant squared. At no time did I manipulate that. I started with one side, moved things around, did algebra until I turned it into the right side.